This is our patch. It was designed by our crew, mostly Dave Williams. Here's us in the suit-up room. Same as suit-up room, actually, that was used during the Apollo program. Here's Charlie getting his gloves on. Tracy, miraculously poised for a first-time flyer. The juror on the crew. And Dave Williams relaxing. And there's Barb looking also very poised for her first flight, as well as Al. We actually walk out of the suit room about probably about 3.5 hours prior to launch. We actually don't walk this fast. I think this is sped up a little bit. It's kind of hard to walk in the suits. And here's Endeavour on the launch pad. Endeavour had not flown for several years, and it was really an incredible vehicle. This is us in the vertical getting into our seats. Crew members in the white room. The white room attaches to the side of the orbiter. This is a view from the middeck. And Rick Mastracchio, he's one of the last guys to get in as mission specialist number 2.
During the launch, we spent a lot of our training, I'd say just roughly 60% of our time getting ready for this specific event. The whole thing happens in 8.5 minutes. The orbiter, when you get there, is just a living, breathing thing. Everyone's been cleared away from 3 miles. You know you're about ready to go for the ride of your life. Here's a little inset photo of what it looks like from inside the cockpit. The jostling you get is when the solid rocket boosters ignite. They're about 2.5 minutes for their phase of flight, and when they ignite, there's no doubt in your mind you're going somewhere, and you're going somewhere in a hurry. We have some pretty good sound here. It's just not coming up. The whole ascent phase, 8.5 minutes. You know, you get up there, the main engine's cut off, and within that period of time, you're now trying to figure out, with 60% of your training done, what you're going to do for the next 2 weeks in the mission. Pretty good shot here of the when the solid rocket boosters separate, and we separate away from that. It's a pretty smooth ride now on the main engines. You go from about 2 some G's on your chest to about 1. And then as you burn down the fuel, you get to about 3 G's. It gets kind of hard to breathe. You really got to be deliberate in your actions. Kind of hard to move around. You're kind of pinned to your seat. And then as soon as the engine's cut off, you're just thrown forward in your straps.
And as soon as you do have main engine cut off, both Dave and myself unstrapped from our seats and grabbed cameras and then shot video and still photos of the external tank as it fell back down to the ocean. And those pictures were later analyzed by our teams on the ground. Then on flight day 2, we got busy. We unearthed the orbiter boom system and began inspecting both the wing leading edges and also the nose cap for any damage that may occur on ascent. On the 3rd day, we began our rendezvous phase to dock with the International Space Station, and you can see here the photography of us getting closer and closer as we approach.
Yeah, because of the damage to Columbia, we now do this rendezvous pitch maneuver, which allows actually the autopilot is flying the vehicle, but we go through this 360-degree pitch to take pictures of the bottom of the space shuttle from the International Space Station. The crew members are snapping a lot of photos here, and that's to just document how the bottom of the vehicle looks. Here's a picture of Endeavour as we approach the International Space Station. At this point, I would be manually flying Endeavour and trying to bring the 2 vehicles bringing together like we see here, although this is, again, sped up. Didn't really actually dock this fast. Probably would have broke something.
Do we have capture or not?
Not free capture.
We have free drift.
With us together, finally, the next thing is to seal the hatches between the 2 vehicles so we've got an airtight seal. And this is us working that right now. Once that's done, it's time to go aboard the space station and begin working. It's kind of like a debut night on any movie in Hollywood where the paparazzi await. I believe at this point there are probably more cameras than there are astronauts aboard the space station out available at this time. And here are us greeting the crew and comparing our photographic equipment.
After we said our hellos, it was time to kind of get ready to do the rest of the day's work, getting ready for the next day's spacewalk, and also Tracy and Scorch here, Charlie Hobauer, were getting ready to hand off S5 to start the next day's activities.
And you see that here in the video. The shuttle arm is grappled to the S5 truss and handing it over to the space station arm for installation on the next day with the EVA crew members outboard. And there you saw a picture of Charlie at the workstation, the robotic workstation, as he maneuvered the truss element to its position.
Although the S5 isn't very big, it's very, very important.
Absolutely.
Now, one of the really exciting parts of the mission was the coordination between the robotics and the spacewalks. And Rick and I are coming out of the airlock. We're translating, moving hand by hand out to the S5 area where Scorch has brought S5 up. Rick and I watched and monitored as Scorch brought the S5 into the soft capture position. You can see the pins dropping down. And then our first task was to drive the large bolts that hold S5 in place. So we got these foot restraints, we moved them into position, climbed into our foot restraints and drove those bolts. And it was pretty amazing actually watching S5 finally get attached to the station, realizing that we're expanding the station in length.
Of course, meanwhile, inside we had lots of transfer, about 5,000 pounds of cargo to bring aboard the space station and 4,000 pounds to bring back down to Earth, as well as a bunch of repairs on this whole station. And there's a Scorch down there replacing one of the scratch panes on the window.
On this day of the flight, this is the day after the first EVA, we did what's called focus inspection. We had to move this boom from the payload bay of the orbiter using the space station's robot arm, then hand it off to the shuttle's robot arm, very complicated robotics task, and that's so we could go underneath the bottom of the space shuttle and take pictures of the spots of concern on the bottom of the vehicle. And here was the main damage area that we had.
On our second spacewalk, we went outside to replace one of the gyroscopes on board the space station. There are 4 gyroscopes that are used to stabilize the position. Rick is now removing the covering of the gyroscope that we replaced, and all of these are up on an area of the station in the center of the station called Z1. So Rick and I came out of the airlock and translated up hand over hand to Z1 to be able to uncover the CMG or the gyroscope and be able to replace it. We use drills essentially like a power tool on the ground. We put a socket on there and we undid the various bolts that were restraining it. Rick then grabbed onto the CMG, which weighs about 600 pounds, and he did what we call a layback maneuver, kind of bending backwards at his waist to be able to lift the CMG out of the way, and then he handed it off to me and we restrained it temporarily, putting it on what's called a mutt ball stack mud. It's basically a tool to restrain it to the space station. I climbed onto the end of the robotic arm and Scorch did an outstanding job driving me over to the payload bay to get the new CMG. This one weighs about 1,200 pounds, and I spent a lot of time in the gym getting ready to be able to lift this thing out of the payload bay. But surprisingly enough, it was a lot easier than I anticipated, and Scorch moved us out of the payload bay. We had about 2 inches clearance from something called the nitrogen tank assembly that was right beside us on the stowage platform. That's a pretty spectacular view. You know, I'm glad somebody recorded this because all I saw was this big CMG that I was holding in my face. I didn't get to see the view. That's kind of what I was seeing, except I saw more of the gyroscope itself. But we brought the old one down to one of the work sites on the stowage platform on the space station. Rick came back from the payload bay. We kind of rendezvoused and put this new one here on the stowage platform. And then we essentially did the swap, taking the new one and replacing it with the old one. But to do that required us riding on the arm back and forth between all the various work sites, and Scorch drove me back up to pick up the old one that had failed, and Rick and I finally installed that and swapped it on the external stowage platform.
Well, there are several different ways of building the space station, and you've seen a couple examples. We put the truss on with robotics and spacewalking, and the gyroscope with robotics and spacewalking. This particular payload that we're taking out of the payload bay right now with the shuttle arm and handing it off to the station arm is a big stowage platform that we attach to the International Space Station. And that was all done robotically by handing it off from one arm to the other and then floating over to the International Space Station side and using the computers on board to send commands to latch the this platform to the International Space Station. And this platform holds a bunch of spare equipment for future uses on the International Space Station.
And this type of equipment will be really important in the future as we stop flying the space shuttle, to have a spot for external spares.
Next thing we got to do was education, talking with school children, this time to the Challenger Center just across the river in Arlington, Virginia.
And that was our way of honoring the Challenger crew from years ago. Our favorite education thing that we did on orbit, besides having fun here, to show Newton's laws, we took up that pink package that you see there has a whole bunch of basil seeds. We took up 10 million basil seeds, and they're getting ready to be distributed now to schools all over the country, and I hope all you kids in here make sure that your schools get these as well. And we'd like to challenge you to help us help answer one of the many, many questions that we're going to need to figure out when we send people back to the moon for the long haul. And how are we going to feed folks? So we'd like to challenge you to design some growth chambers that can be used on the moon. And who knows if basil's what you'd want to grow? It's all up to you to help us decide.
I was concerned some of those 10 million seeds were going to get away, but fortunately they didn't. So it would have been a mess.
What they did was gave a beautiful aroma inside the space shuttle and space station.
Before every EVA, there's a tremendous amount of work that takes place inside the airlock, just getting the guys ready, or gals, ready to go outside the hatch. And so you see footage here of Scott spent most of the morning getting these guys dressed up and in their suits and pressure checks, and then I would come in later on and help put their tools on them and get them packed inside the crew lock and ready to go out the door. You can see it's not a whole lot of room to work, but having no gravity sure helps. Once they're tucked inside the crew lock, then we shut the hatch and then begin to depress the airlock and start getting the guys out.
So on the third spacewalk, Clay Anderson and Rick went outside to do that one. I was actually inside for that spacewalk. Clay did an absolutely outstanding job, and as you all know, he's still in space right now. He just celebrated his 100th day in space. But this was a spacewalk that was essentially focusing on communication equipment, and there's a great shot of Rick on the end of the arm. He had to transfer what's called an S-band antenna, and this is essentially part of the communication system for the space station, and we're moving things around just to allow us to move that large section in the center of the station called P6 out to the port side of the station. So Rick had to move some of the equipment from P6. Clay was also working to install what's called a BSP and transponder, again, two elements of the space station communication system. After they did that, we had to move these CETA carts, and the center of the space station is this long truss, and on that we have the equivalent of a railroad, basically, and these CETA carts allow us to put equipment on and move the equipment from one location to another on the station. But we needed to move these to the starboard side of the space station. There was a great shot of Clay up on the end of the arm, and during this whole process, at some point, Rick got a nick in his glove, and this is a shot of him looking down at his left glove, showing where the nick is. We terminated the EVA a little bit early, came inside, and then Clay and I took some photographs of the glove to be able to send it to the ground for analysis.
And because of the damage we had on the bottom of the vehicle, we were talking about maybe doing 5 spacewalks, perhaps the longest shuttle flight in the history of the shuttle program, to repair the damage. But all the analysis that was done on the ground determined that that wasn't necessary. And then we had Hurricane Dean, as you can see here, brewing in the Gulf, and we had to go from figuring out how to fly maybe the longest flight to now try to do everything we needed to do in much less time. Our last EVA, as you see here, and then close the hatch early and undock early and come home.
So for the fourth spacewalk, Clay and I had a chance to go outside and do that one. As Scott mentioned, we changed the choreography of the spacewalk literally the night before to shorten the spacewalk to enable us to get back in earlier, to close the hatch, to be able to undock. The large structure that you can see on the side of one of us is a stanchion to hold this boom on the space station. When I came out of the airlock, because of all the things that were in the airlock, the hand controller for my jetpack, if you will, deployed itself. And when we do a spacewalk, we always wear this thing. It's called a safer that enables us to fly back to the space station if we inadvertently came off structure and the hand controller for mine kind of popped out. There's a great shot of us translating up to the work site. After we installed these stanchions, I went and worked on another communication antenna to lock it in place to enable us to move P6, and at the same time Clay was out working to retrieve an experiment that had been put outside in the space station, and he's now getting ready to bring this back inside. You can see him going to stick that on the end of his BRT, which is a tool that you use to grab onto things when you're out in space. After we finished that off, we went to the end of the lab and installed an EVA antenna system that allows us to take these kinds of images from our helmet camera. Tracy said, "Hey guys, look over your shoulder," and we looked down at Hurricane Dean. It was going by underneath us. Absolutely spectacular view. But we wrapped up the spacewalk after about 4 hours or so and got ready to come back inside, closing the thermal cover and the hatch to the space station's airlock, get ready to undock.
And with that, it was time to say our goodbyes. Here we are saying goodbye to Fyodor Yurchikhin, Oleg Kotov, and Clay Anderson.
Undocking is a pretty fun event for me. It's the one flying task I get to actually execute. If anyone would like the landing, that wasn't done by the pilot, it's done by the commander. I guess Bob Crippen and John Young back in the day didn't want to have a guy named a co-pilot, so they call him commander and pilot instead of pilot co-pilot, but I'm really the co-pilot. So Scott flies the docking, I get to fly the undocking, and this is a space station as we're separating away. And then, of course, Scott will do the landing. For our flight, again, it was pretty busy on undocking day. You basically wake up in the morning, get ready to punch off when the lighting is correct. You get everybody in position. You got 7 people cluttered on the flight deck. Everybody wants to take pictures, get a piece of the action, and somebody in there is supposed to actually safely separate from the station. That's supposed to be me. It was really a pleasant event. My first flight, I got to do a full fly around. We actually shot a 3D IMAX video. For this one, we just separated out directly ahead of the station and then did what's called a separation burn, where we just do about a 3 foot per second acceleration to get away from the station. And after we did that, you're pretty much in a safe trajectory. And we really took a long time to take a bunch of great pictures of the station.
A couple days after we undock, it's time to come home. Here's a view of the flight deck of us back in our pressure suits that have been put away for about 2 weeks.
3, 2, 1. Easy left turn on the heck. Light winds all the way around.
And here's a view of from the ground of the shuttle as we fly around the heading alignment cone. And you can hear some of our cockpit audio, so I won't talk a whole lot over
overlays. Good, good. 3,000. Speed brakes going closed. Looks like about 7. Okay. 2,000. Pre-flare. The pre-flare. Arm the gear. Gears arm. Got a light. 1,000. 307 max. 9, 8, 7, 6, 5. Gear 3. 400 feet. Gears on the way.
Shuttle's a big glider.
Good energy through the threshold. You're on the ball bar. Good job. 5240, 4235, 3230. Let it keep coming. 2225, 10220. Good left correction. Your touch.
We had some crosswinds to contend with during this landing. That was you can see in this video.
All right, good.
Only one of
All right,
us
nice
could
job,
actually
Scott.
feel. Only one
All
of
right,
us
nice
could
job,
actually
Scott.
feel the wheels touch down.
Congratulations, welcome home. You've been given a new meaning to higher education.
After the flight, we had the opportunity to walk around the bottom of the shuttle. We're actually kind of dizzy here, and we're trying not to look like we're dizzy. And here's us looking at the damage. Quite underwhelming, I think, was what I thought about the little ding on the bottom of the vehicle.